All right, I'm about to run a couple of famous experiments on you, right here, right now. They reveal something absolutely fascinating, and frankly, a little weird about how your mind works when you have to make a choice. So let's find out if your brain actually plays by the rules.
Okay, for this to work, you've got to play along with me. Imagine you have a shot at winning millions of dollars. Your decision could make you incredibly rich. You ready?
Seriously, there's no right or wrong answer here. I just want you to go with your gut. Which one of these two options just feels like the better play for you?
Okay, let's break this down. Gamble A is a stone-cold guarantee. You walk away with $5 million, no questions asked. Then you've got Gamble B. It's got a super high chance of winning that same $5 million, a small chance at a whopping $15 million, but, and this is the kicker, there's that tiny 1% chance you walk away with absolutely nothing. So, what's it going to be? Go ahead, lock in your choice.
Got your first choice? Awesome. Now, I want you to completely forget about those options for a second. We're going to play again, but with a different setup. Again, just pick the one that feels right. All right, check out Gamble C and D. With C, you've got an 11% shot at $5 million. With D, the odds are a little lower, just 10%, but the prize is way bigger, $15 million. Now, you'll notice the chance of winning nothing is pretty high for both. So which one are you going to take a chance on? Okay, time for the big reveal. Here's what's wild. For decades, researchers have run this exact test, and the vast majority of people, they pick Gamble A in the first round and Gamble D in the second. If that's what you did, hey, you're in good company. But here's the twist. That very common, very human choice, it actually breaks a fundamental rule of rational decision-making.
So, why is that combo, A and D, considered so irrational or paradoxical? Well, to get it, we need to talk about a core idea from economic theory. An idea that, it turns out, our brains just don't seem to like very much.
It's called the Independence Axiom. Now that sounds fancy, but the concept is super simple. Look, if you prefer apples over bananas, then you should also prefer apples and a free cookie over bananas and a free cookie, right? The cookie is the same on both sides, it's totally irrelevant, so it shouldn't suddenly make you want the banana.
Okay, so watch this. This is where the magic happens. We can look at that first choice a little differently. See that? Both Gamble A and Gamble B have an 89% chance of winning $5 million. That's our free cookie. It's common to both options. So according to that axiom, we should just ignore it. It should cancel out. So if we take away that shared 89% chance, what were you really choosing between in the first round? It was an 11% chance of $5 million versus a 10% chance of $15 million. Now, look at the second round. The choice between C and D, it's the exact same dilemma. So if you chose A in the first round but D in the second, you've literally just contradicted yourself. You picked one thing and then immediately picked its opposite.
And this is what's really going on inside our heads. It's a powerful bias called the certainty effect. That 100% guarantee in Gamble A, it's like a siren's call. It's irresistible. Our brains don't process probability in a straight line. That leap from 99% to 100% feels huge, way bigger than the leap from, say, 10% to 11%. We are just hardwired to love a sure thing. Okay, you ready for another one? Let's try a different puzzle. This one isn't about the allure of certainty, it's about how our brains deal with something else we hate, the great unknown.
I want you to imagine an urn, like a big vase, filled with 90 balls. You know for a fact that exactly 30 of them are red, locked in. The other 60? Well, they're a mix of blue and yellow. And here's the crucial part. You have no idea what that mix is. It could be 60 blue and 0 yellow. It could be 1 blue and 59 yellow. You just don't know.
So the game is easy. You're going to bet on a color, we draw one ball, and if it's your color, you win $100. Simple enough, right? So for round one, which bet are you going to take?
So you can take bet A, and you win if a red ball comes out. You know the odds there perfectly. 30 out of 90, that's a 1 in 3 shot. Or you can take bet B, where you win on blue. But remember the number of blue balls? It's a complete mystery. So what's your pick?
Okay, so most people, they go for bet A. They like knowing the odds. Now let's reset. Same urn, same balls, but a different pair of bets. What do you choose this time? All right, in bet C, you win if it's red or yellow. And in bet D, you win if it's blue or yellow. Now think about this for a second. Bet C is ambiguous, right? We don't know the exact number of red plus yellow. But bet D, well, you know there are exactly 60 balls that are either blue or yellow, so that's a known 2 in 3 chance of winning.
And just like in the first experiment, most people are incredibly consistent. They pick bet A in round 1 and bet D in round 2. And you guessed it, while that feels totally natural, it's logically inconsistent. It reveals another one of our brain's little quirks.
Just think about it for a second. If you chose A over B, you're basically saying you think there are fewer than 30 blue balls. That's why you took the known 30 red ones. But then, by choosing D over C, you're implying you think there are more than 30 blue balls. It's a complete contradiction, and it's all driven by one simple feeling. We hate not knowing. We'll always take the devil we know.
This has a name, of course. It's called Ambiguity Aversion. We are just systematically drawn to options where the probabilities are known, even if those known probabilities aren't actually better for us. The unknown, the ambiguous, it just feels risky and unsettling, so we steer clear, even when logic tells us we might be missing out.
So, we've put your brain through a couple of mental workouts here. What's the big takeaway? These two famous paradoxes, they're not just fun little brain teasers. They peel back the curtain and show us the hidden psychological forces that are constantly shaping our choices.
You see, a lot of standard economic theories are built on this idea that we're perfectly rational, that we're like human calculators, but we're just not. The Allais Paradox shows how our powerful love for certainty can make us totally inconsistent. And the Ellsberg Paradox, that reveals our deep, deep dislike of ambiguity, of the unknown. The bottom line is, our decisions are driven just as much by our psychology, by our gut feelings, as they are by pure logic.
So here's the final thought. Knowing about these biases doesn't magically make them disappear. But it does give you an advantage. It gives you awareness. The next time you're facing a big decision, a choice between a sure thing and a maybe, or between a risk you understand and one you don't, you can pause for a second, and you can ask yourself, is my brain actually crunching the numbers, or is it just doing what feels safe?